All right, create a new project, and this time click on augmented reality app. And call your product template or something, or AR. Oh, all right, that's you can directly write Mars in the living room. We'll modify this, but you can call this Mars in the living room. We're going to bring Mars in wherever you are, not living room really, but in the room. So Mars in the room is the basic project we'll be working with. Uh, One interesting thing that you'll see a team name, your organization identifier, but one interesting thing that see is the content technology. There are four different technologies. RealityKit is the latest framework which is used for integrating videos to AR, and it also does images. But RealityKit is for basically putting in videos into AR, and we'll see that too. Um, SceneKit is so AR. So RealityKit very recently came out. I think about a year back. I think SceneKit is has been there for about 2 years now. So and SpriteKit is the most common. Metal and SpriteKit. SpriteKits have been there in existence forever because SpriteKit gives you 2D graphics. Starting with SceneKit, you get 3D, and RealityKit is also 3D. Uh, you've seen sprites whenever you played any games in your classroom. You would have seen a lot of 2D animations. Like if you played a game called Dave, you will have seen sprites. So that's Sprite Kit. You have Scene Kit and Reality Kit. Scene Kit gives you a lot of functionality. You can also add videos, but it won't be that like you don't get a few advanced features in terms of let's say you are holding a newspaper and you bring your camera in front of your newspaper, and basically through AR, let's say it reads that hey, this is the picture of Olympics game 201, for example, and automatically go to YouTube and play that video in that particular position. So all of that's possible too, and we'll see a very simple application of that as well. So you have Scene Kit, and interface is storyboard and language is Swift. You can click on next and create a new folder. Again, you can call it Mars in the room or call it just Mars and click on create, and also create a Git repository on Mac so you know and you get it saved. So one interesting thing that you will realize is this free membership. Since we do not have a developer account, um, all the free memberships are limited to about 10 installations, right? So 10 bundle IDs is what it means. And that 10 bundle IDs mean that you will soon see an error onto your computer, on your iPad when you're trying to build, in fact, in your Xcode, because you would have completed those 10 installations. So basically, in that case, what you have to do is the bundle identifier, it should be the same as your other bundle identifier out of those 10 applications. I choose one of mine called MON because I know that that's going to be there. So the content technology I selected is SceneKit. So yeah, so remember, whenever you see an error, I'm not sure if you've encountered it, but more apps you build, that higher chance of that error coming in. So just have one bundle identifier that you know that there is. And yeah, with that, uh, directly connect it to your iPad and click on build. All right, it comes with a template. And once you build, you'll be able to see a ship. This is the error I'm talking about. If you see, it says communication with Apple failed. Your maximum app ID limit has been reached, and you may create up to 10 every 7 days. All right. In this case, I need to find out. So if you also see it, you just find out the one that you know is going to be working, and you just make the changes right here. I'm just going to try out with this. All right. And once you build it, please write fried rice in the chat box again. I'm going to find out one of the bundle identifiers that's working for me. All right. Just give me a moment. All right, that's interesting. I shall fix it, but let's keep on going. But I hope you can see the result. I'll show you the result too. Just give me a minute. All right, so you'll be able to see something that looks like this, right? In your living room. And let me see the chat box. I see a lot of fried rice. That's great. Now, this is because of one fact that this is a template. You didn't even have to write a single line of code in order to see this because it comes with Xcode whenever you run ARKit. And it's essential to identify what exactly is happening here, how this image is created, and why is this all happening. Firstly, click on the assets folder. One interesting thing that you'll notice is with the assets folder, when you click on art.scn assets, that will be a different assets folder. So you'll be able to see two assets folder. Assets folder one is going to be the one that we are used to creating, which you'll also be using. But also along with that, you'll have a scene assets folder. In ARKit, you'll see a lot of SCN stuff. SCN stands for scene because we are using SceneGit. And SCN assets folder is what is going to be useful whenever you're doing any of the operations. When it comes to creating an image, in fact, even with the code, so we are going to do it two ways. One is you can directly add objects here. So if you click on the object library, this will be very different. You won't be able to see buttons. You won't be able to see text boxes here. You'll be able to see all the different stuff. Like you'll be able to search for a box or even a sphere. So that is going to be a huge difference as compared to what we've been doing so far. And the reason for that is this uses the scene kit delegate. And we've used delegates since quite some time now, from text field delegate to even for ML, right? So this is again a delegate pattern, and this allows you to use the scene kit stuff. So click on art.scn assets folder, and then now what you need to understand is how did this image actually look like this, right? So if you expand the scene graph and the ship mesh, you will see a couple of parts, and also open attributes inspector along with that.
How do you get to scene graph?
I'm sorry. So can you say that again, please?
How do you get to scene graph? Like scene
Oh, I
graph and
see.
ship?
Oh, sure. So please locate art.scn assets folder. Do you see that?
Okay.
Expand it, and over there you will see ship.scn file. All right. And so along with that, you'll be able to see the texture file. And if you see, this texture file is nothing but the texture is actually loaded onto this graphic, right? And how did that happen? And how do you see, or how do you make that happen? So in order to see what exactly is happening, if you click on the ship, right, you'll be able to see firstly a lot of things like the position, the x-axis, the y-axis, the z-axis. When you click on ship mesh, you'll be able to see the same. However, one interesting thing that I want you to kind of observe is the node. what you see here and what I'm getting to is how to create this when you're typing the code. Because so why are we learning ARKit? To enable image detection using ARKit, right? So you can just put in some boxes here and you can see it on an iPad and you can play around with it, right? But we want to enable more functionality than just that. You just don't want to see some images in front of you. Uh, what you want to see is also ARKit, your camera being able to detect that image and match it with the images that you load in the assets folder, right? And that's how image detection would be done. Your ARKit would be able to locate, or your camera would be able to locate an image. It will match it with a resource file kept here. And then if it matches, your ARKit will actually create a plane there or even put in some information based on what application you're trying to create. So in order to kind of in order to make that happen, you need to understand how you need to type your code and how objects are created in ARKit. So if you see the ship, if you click on ship, you will see a node pop up. So again, I'm saying node is because this is a scene. All right, this is an entire scene, just like we have in movies. This is a scene. Inside the scene, you have a node. So every scene will have a node, and to that node, things would be associated with it. So if you see here, the ship node, which is this node, has a ship, right? Which is a ship mesh. If you want multiple ships, you can have multiple ship meshes. All right. And in a scene, you can have a lot of objects as well, right? But remember that the first thing that you have is a root node. To the root node, you have multiple nodes. Now, to each of these nodes that you see here, uh, one thing that you want to observe is uh, the ship mesh. If you click on the attributes inspector, you will see a couple of things there. So if you click on the ship mesh and not in the attributes, you can click on material and you can see the material selected is this texture. All right. And this texture file has been loaded here right below the ship.scn file. So what I'm trying to get to is if you see the ship mesh has a property in which the property's name is diffuse, and the diffuse property has a texture associated with it, right? Which is actually changing the way this ship looks like. You can also play around with it. You can change the color or you can choose the texture, right? The image file. And that's how the texture is being loaded and that's how you're able to see this. Now, what you need to understand with 3D based system is 3D geometry. So please click on the ship node, the main ship file, and see this node that you see right in front of the ship. So very simple math, okay, nothing really fancy or very complicated. This is 3D space, so you have 3D geometry, which means you have three axes. You have x-axis, y-axis, and the z-axis. Right here, what you want to see is, can someone tell me, okay, so open question. The plane or the ship that you see right here is related to this node via which axis? Can someone tell me? So what? So if you see currently, the ship that you see is currently related to this node through which axis? How do you make the ship go behind? Like let's say it's behind this node. So which axis has been used? Can someone tell me?
The x-axis.
All right. Anyone else?
Y-axis.
All right. And
Z-axis.
perfect. That's correct. So the reason it is the z-axis. So remember, when you're talking about 3D space, you have three axes: x, y. So let me bring in the annotation. So you have the x-axis that you see here. All right. You have the y-axis, which is again the one that we are used to seeing. All right. This is 2D geometry. But when you talk about 3D, you have something called as the z-axis, also the depth. All right. And this depth is going to be very useful in 3D space because if you see your aeroplane right here, the ship, one thing that you will notice is that you'll see the red, which is the X, green, which is the Y, and the Z axis, which is the blue. And if you hold it, right, if you click on it and you move it, you'll see the ship go back and forth. However, what you want to see is how the ship, all right, so now what you want to do is, I hope you all tried to run and build your application and you were able to see the ship in front of you, right? Uh, Also, now you want to see how to bring it behind you in this entire scene. In order to do that, what you want to change is the position of the ship from the Z axis, based on the Z axis. So again, I hope this is not boring, but you have the positive Z here, you have the negative Z here, right? What you want to do is you want to change minus to plus. So how would you do it? So click on the ship, open inspector, and open the position, where you'll see a cube system here. All right. Oops. And click on ship mesh, open the position. Uh, and now you'll see z-axis as minus 0.8. So please change that to, let's say, minus 2 and see what the difference is. If you change it to minus 2, so again, click on ship mesh, open the attributes inspector, click on position, and then click on minus and change the z position to minus 2, and then click on ship. So basically what happened is, if you now click on ship, you can see from the parent node, you'll see the ship actually move away from it, right? So right before you build, now if you click on ship mesh and change the Z to +2 and build your application. And when you build it, this time you won't be able to see the ship in front of you, but you'll actually have to rotate your iPad or iPhone and see behind. And if you see that, please write coffee in the chat box. Again, all you have to do is you have to click on ship mesh, change the position of Z to 2, positive 2, and then build your application. I'm just finding out one of this bundle IDs to make my app work too. All right, I see 3 coffees waiting for a few more. Let me open the hot dog app. All right. So I see a few more coffees, so I'll proceed again. We'll come back to this very soon. So what we've seen, so I hope you understood what the logic is once so I hope you were able to see it behind you this time. Can someone just confirm if you're able to see it behind you? So when you change it to from negative to positive, you're able to see it behind you. Please write yes if you were able to see the change by changing it to positive. Were you able to see the ship behind you this time? Can someone confirm? All right, it was in front of you.
I have to connect my device again. I don't know why I'm having a device connection issue.
All right. So Jira, did you find any difference between the positive and the negative? Oh, not really. That's interesting. Did you change the z-axis? Of the ship mesh? All right. The reason being, if you see the ship, all right, great. So yeah, please try it again. Because if you see the ship, once you change it from negative to positive, you see the ship actually going behind the node. And if I change this ship mesh from from positive to -5, for example, and now if you see the ship, you'll see it far away from the node. All right. So yeah, just this is basically playing with 3D geometry. But one interesting thing that you'll observe over here, except for all this, is remember that you have a node and that node has a parent. So this is the root node and that has a child node. All right. And you can also do the same if you want to. So what you can do is you can click on delete node altogether and you can click on plus. So again, oh, sorry, please delete whatever you see in the ship.scn folder or ship.scn file. So please delete what you have, select and delete. And click on plus for the, and you rename this scene graph. So you can rename it, open the attributes inspector and change the name from shape to, again, you can probably call it a box. So call the scene a box. And this time we are going to create our own object. And now what you want to do is the first step is to add a node. So click on plus sign and you can add an empty node. So in fact, this box is a node because we just click on plus and it creates a node. So this is your multiple nodes, but you can add another node or you can directly add an object. So click on, I would say just add an object instead of multiple nodes. Sorry about that. And search for a box and add it to your node that you see. Maybe a tricky thing to do, which is to make sure to drag the box under the parent node. All right, so you probably, when you drag the box from the object library, so if you open the object library, search for box and drag it, you will not be able to actually drop it within this node. So first drag it outside and then try to place it within this node. And once you're able to do so, please write yes in the chat box. All right, so if you see, The reason we are adding this box is to see, firstly, observe that you have something called as a box. Search for sphere and add that sphere to the scene graph as well. Make sure it is apart or it is inside the child node or inside the parent node.
Professor,
Yes.
this is probably a stupid question, but I can't get that pane to open that says scene graph.
Oh, I see. No problem. In that case, what you'll be able to see is, let me just close this. So if you see next to the camera, which has perspective, probably, you'll be able to see an icon that looks like this. Do you see that?
Um,
Can you see my mouse?
Excuse me?
Can you see my mouse?
Yes.
All right. So if you see at the bottom part of the screen, you see this icon.
No.
All right. Okay. Do you see the left pane?
Yeah, I do.
All right. In that case, just give me a second. Click on view and view. Just give me a minute. All right. I see. Okay. In order to actually open this, can you first click on art.scn assets? Can you open that folder, expand it, and click on ship.scn?
Okay.
And do you now see it?
No, I've had that same file open the whole time.
Oh, even ship.scn as well. So you've clicked on ship.scn
Yeah.
and you do not see this expand icon. Is that
No.
correct? Oh, no problem. In that case, right click on art.scn assets folder and click on new file.
Okay. Oh,
How do you
okay. I see it. Yeah.
Oh, perfect. All right. So yeah, you can probably call it ship only, or you can call it anything. You can just call it as such. All right. Cool. Yeah. So, and then the first step is add a child node. Firstly, add an empty node from the object library below the camera or away from the camera separately. So the main point everyone we are observing here is everything that you see here is something that you can type and get it also. So the first step, remember you have a scene to which you add a node, a child, an empty node or a root node. To this root node, what you add is an object, all right? And this object can be a box, it can be a sphere, and all these objects that you're typing are a part of the scene kit delegate. So even that you see a sphere, all of these are a part of the scene kit. And it's really simple to bring them. And one more thing that you want to observe is when you click on the sphere, hover to the right side of your screen, and you'll be able to see all the properties associated with it. For example, we expand it, the radius of the sphere. So click on sphere because we are bringing in Mars to our room, right, with code. So click on the sphere and observe the dimension. So you have the radius. Another thing that you want to see is the texture. So what we want to do is basically, how do we bring Moon or Mars to our living room? By bringing in a sphere and wrapping it with a texture, just like we saw in that ship. So if you see the diffuse property, that is how we can change the color or the material, right? So that's the next step. We need a material, all right? And you can build the app and it's that easy to see everything on your screen, but we'll be coding it out. We want to actually understand the code now, all right? So again, what we are planning to do now is we're going to, with code, bring in a sphere into your scene, into your AR kit when you open your camera. and wrap it with an image, again with a code. So in order to do that, please, please open solarsystemscope.com. I'm putting the link in the chat box. And this is a website which will give you really high resolution images. Actually, you can choose whichever planet you want to really. But yeah, so you can choose, please visit this website and download a high resolution, in fact, ultra resolution image of any of this. I would select the Mercury, or I'll select the Mars one. So click on download and save the image file as a simpler name. It says 8K Mars, you can just make it Mars. You can drag and drop it into the assets folder. I mean, I would just save it and then drag and drop. That'll be much easier. So save the file and drag and drop it into the assets folder. And you can delete the ship and SHSCN, all right? So we don't need this anymore. Whenever you open an ARKit project, you will see it up here. So the downloaded file that you see should be pasted in the art.scn assets folder. And once you do this, please write Mars in the chat box, or whichever planet you've chosen. I see 4 yeses, waiting for a few more. And I see 5 Mars. All right, okay. Now, what you want to see is the code. So click on view controller.swift, and this is where you want to observe how the coding is done in ARKit. Again, this is the template code that we saw, right? This is what it comes with whenever you open an ARKit project. So if you see this code, now that we've done so many codes, it's super easy to understand a lot of things about it. Firstly, if you see the view controller, it takes in stuff from UI view controller, which is great. But if you see, just like we've done the UI text field delegate, it uses or implements AR SCN, which stands for AR scene view delegate. All right, so 2 things are implemented, but we are implementing a delegate pattern, which means some things or some set of rules are going to be implemented. Basically, the scene view comes with a lot of inbuilt abilities, which allows us to do a lot more things. Then, if you see, the scene view is linked here as an IB outlet, because if you click on the main.storyboard, you will see scene view. Just like we have a table bar view controller, you have this. All right, you have a scene view controller. So basically, a scene view is not a controller. It is going to be like a text field which is placed on top of a view controller. That's why you have to link it, and which uses and it inherits all the properties from the AR scene view. And you see an exclamation mark because it's force unwrapping. But again, it's already a template, so you won't find errors with this. Next, you have the view did load, which is what happens when you run your application. When you run your application, you see a delegate, because this is how we set a delegate, right? Scene view, which is the name of the object created. If this was a text field that we had taken in, we would have written text field dot delegate equals self. And what this does is that you firstly have implemented ARSCN view delegate. You said that, hey, I'm planning to use this. But when you declare it with a particular object from a particular class, this means that now you can implement it in your code. So now when you write scene view, you get a lot of abilities. In fact, you have a lot of functions that are inbuilt that you see right here. So I mean the next part, which is show statistics. So when you will run your app and when you would be able to see a lot of statistics pop up below, like frames per second. And that's because of this line of code, which is scene view.show statistics equals true. And that's it. And then a scene has been created. So again, if you see, we had the ship mentioned, right? And the ship was a scene. If you right click on art.scn, create a new file, you get a scene file that's created, right? But we are planning to create it using code, right? So please do not do this. But we are planning to do this using code, which means if you see the view controller, um, a new scene has been created. Basically, you can think of it as a constant that inherits the scene from this particular view and this scene is getting added to our scene views property called scene. All right, again, what we are doing is there are two ways to do this. All right, so let me just write this down, 1 and 2. The first way is like we saw, which is you click on art.scn folder, create your own scene and add objects to it, all right, manually, which is add a sphere, add a box, and so on. The second way is to create your scene and add objects and its functionalities with code. All right, so this time we'll be creating sphere with code. And there is a reason for this. The main reason is if you have created everything with code, you get to modify those properties. As compared to when we are talking about buttons in our normal application, in single view applications, in which we connect these buttons to our code, right? And we can modify them. Here, modifying each object is a huge challenge. So basically you create your own objects with code and then you can just play around with them. And it's a very simple process to create objects with code. Another thing that you want to see is this first line, your own scene, create your scene, which basically means if you see this line, this is from the template, which is this first part, which is a scene has been created with objects dropped manually. In this, what is happening is we use the scene from the AR kit, and you pass in the name of the folder where that scene is, which is this folder right here. All right, and then you pass this scene and run it right here. All right, and these two lines, if you delete them, you get to create your own code, and basically you create your own scene, add nodes to it, add another node to that node, add another object, and link that scene right here. So what I'm coming to is these two lines of code are useful if you're manually putting in things, but when you're coding it out, you do not need them. So please select them and delete them. And then I've put a couple of steps in the chat box, so please copy them and paste it right there, right in the view.did.load function. Once you paste it, just add another step, which I've not added, is add to scene. And these are the 1, 2, 3, 4, 5, 6 steps to adding anything to your ARKit views. And they are really simple. Basically, if you had to manually add it, you click on the object library and add it. Here you have to type it out. But it's very simple as well. So if you read them, you have a sphere. So please add this or add these, paste it in your code because it just makes the task entire really easy. Because it becomes a step-by-step process. And this will be helpful when you're actually implementing your own applications. So these are the common steps. And where will it be helpful, right? So if you're wondering if you're creating an image detection application, why do you need to even bring a sphere, right? Or why do you even need to bring a plane? You will require these steps in your AR app when you are doing image detection, because when you find that object, you want to add a plane in that location of that object. To that plane, you will add some information that if you're detecting a person, if the camera is in front of me, it will add a sphere on my face. And I mean, that's how you do it in a code. You'll have a sphere on my face and my name would be written right here, right? Something of that sort. That's why, remember, if you're doing an image detection application, you need to know how to write and create an object with code. So very simple. You have a sphere. So first, yeah, Eamon wanted to say something? Okay. So you add a sphere. So to add a sphere, you write firstly create a constant called sphere, and you. So that's it's really simple. All right, to create all objects, you just write sphere. So create a constant called sphere, and to that you need to write scn sphere. That's it. That's how you add an object. But also you want to add the radius. So open parenthesis, select radius, and add 0.5 as radius. And that's how you add a sphere. All right, you just write sphere and you're creating basically an object from the scn sphere class with radius 0.5. Next is the material. Now, this is where, so firstly, double check if you have the image right here. All right. And now what you want to do is you want to initialize a variable called material, because remember, don't follow these steps. I just want to show you something. And if you see what I'm trying to show is when I create an object called sphere, and if you see the materials, and then inside materials you have diffuse, and diffuse over there you get to select the texture, right? And that's how you create that object. However, when you're doing, so this is what you'll be able to see, right? When you add the texture to your sphere. So if you're doing this by writing code, firstly, you need to create an object called sphere, which we just did. All right, we created an object called sphere. Then what we want to do is we want to find material, right? You need to have something called as the materials class, right? Right here, you have this option to just select materials, but currently when you're writing code, you do not. So first step, you want to create something called as materials. Second step, you want to create something called as diffuse, and then you add that image. So basically we are creating this entire pane using code. So this is again very simple who dot what equals value that we had learned at the beginning, that who is what you're trying to change, what about it that you're trying to change, and to what, right? And what's going to be the value. So again, in material, you want to first create a material. So create material equals scn material, open and close parentheses. So that's how you created that entire material pane that you see on the right side right now on my screen. But yeah, basically you just create a material. You can call it materials also, but yeah. So initialize material, and to this material, you want to add the diffuse property. All right. And what's going to be the value of that? It's going to be the Mars.jpg. So what you're going to do now is you're going to write material dot diffuse dot contents. So contents is a property that you'll have to add because that's how you change the value. And now, good question coming in. I want some answer at least. I'm hoping for it. How? So we've done this a couple of times. Okay. How do you add this image name, this image of this particular name to this file? So how do you add that value right here?
You do an image dot value, the file name dot value.
All right. But do we use UI image or something, and then we use the name property?
Yes.
Right. So again, remember for color, we have used UI color dot whatever you want to write, right? Or you have also learned that you can open named and enter a name of that color. There's no color like KLLSKL. But again, similarly, to add an image of a particular name, you write UI image, open parenthesis, and write named. And then in quotations, you enter the name. However, please go ahead and write it. Then you'll realize that there is something that you need to add here. Make sure the image name is simpler. So coming to some command line stuff and thinking about the hierarchy, do you think this file will be able to, will Xcode be able to locate this file by just writing this? Any opinion? Do you think this is going to work? Is this image in the same directory as the view controller.swift?
No, technically it's outside it.
Right? So you need to actually go inside this folder, right? So therefore, you have to specify the folder. Perfect. And in order to do that, just write art. So inside the quotation itself, before Mars, you write art.scn assets, which is the name of the folder, / mars.ceg. All right. And once you change this, the next step is you want to add. So you have your material ready. You want to add this material to this sphere. All right. So that's the next step, which is you want to add it to the sphere. So in order to write that, you want to write sphere, which is what you want to add it to, dot materials equals to square bracket. And again, the reason we are creating a square bracket is because this material object is actually an array. And that's why you have to add it to as an array. This property, if you click on materials, oops. Well, it's not coming, but basically you have to add it as an array. So add it as an array. It's an inbuilt command, sphere.materials. It's coming from this object that you see, the moon, the Mars right here. And it takes in an array, and that's why you have to add an array of materials. And that's completes your addition part, which is for the material. So basically we initialize the material property to get that material the pane, inside which we located the diffuse, because that's how you add a material. We selected the material, mentioned where it is, and added it to our sphere. All right. Again, remember this is an inbuilt materials property. It shouldn't be just material. And now coming to the final steps. You have the sphere, you have the material, but in order to be able to see it, you need to add this sphere to a node, right? Only if it is associated to a node, right? So I'm just actually showing you both the ways of doing it. If you see, this is going to be a node, your root node. So this is your node. So basically this is when you open your camera, and this is the sphere that you will see in front of you, right? At a certain position in front of you, right? So you need to create a node. That's the next step. We initialize a node property to which we are going to add this child node. Basically, we are going to add this sphere to this node, and then we're going to add this node to the scene. All right, and that's the steps that you'll be reading, which is you initialize the node. So let's initialize it. Let node equals scene node. All right, you initialize the node, and then next step is node.position to initialize its position. So also, please at least initialize the node, and then coming to the position, it will be node.position. And then, so firstly, please type it. I just went too fast. So the position, if you see, is going to be. So now, if you see the node, you have position x, y, and z coordinates, which are nothing but called. So we are right here. We are at node dot position, and now you want to have x, y, and z, which are nothing but vectors, 3D vectors. Okay, so that's why you have to call in SCN vector 3, which represents the 3-component vector, open curly braces, and you can select all of those values. That's fine. I'm going to select the one which has an argument label for that ease to see what you are filling and where you are writing it. And you can enter in values 0, 0, and +1 or -1, you decide, and go ahead with that. -1 will be behind you, so you'll have to actually turn, and +1 will be ahead. Or you can figure that out. You can play around with it actually. You can even change the radius, right? So I have added 0.5, which is huge. You can even add 0.25. And you can change the X and Y also, but what that will do is when you open your camera, it won't be in front of you, it will be a little bit on the right. If you change the X and Y, if you change the X axis, it'll be towards the right or the left based on plus and minus. And if you change the Y, it will be above or below. Right? So yeah. And then you have the geometry. So once you add this, you need to write node.geometry equals to that sphere. So basically now you add the sphere, basically the value of that geometry has to be associated with that sphere, because in that node, you can even have a lot of other values, right? So if you see this node can have a sphere, it can have a box, it can have a lot of things. So this position or this geometry is associated with this sphere. Then the last step is added to a scene. So scene view dot scene equals to this node. Or will it be a little bit more? In fact, it'll be scene view dot scene dot. You need to add it to the root. So root node dot add it to the child node. Add it as a child node, and you add the root. So again, to understand this, you need to see this entire thing, which is you have a root node to which you have a node to which you have this child node that you are adding. So basically, imagine that you can have a lot of nodes also, you can have a lot of different objects associated with that node. So the way you add it, so next time you add something, you can directly add to child node. But for now, you can have a root node to which you want to add a child node, which could be this node. And now once you do this, you can go ahead and run the app and you can see the change in your screen. And once you see, you can write Mars in the chat box. And please let me know if you have any questions. I'm going to just pause the screen for a minute to locate one of the bundle IDs. Right, I don't see any chat, any Mars in the chat box. Oh, I see the first one. All right, that's great. All right, I see total four, waiting for a few more. But yeah, this is what was planned for today's class. Now we're coming to the configuration part, which is how to get started with image detection and stuff. But yeah, commit this file. I create an assignment for this, and you have to upload it. I am just not able to build it, trying to locate the identifier. But I hope anyone facing any error, but I can definitely help you out. I've just ran this application way too many times. All right. Let me see the chat box. It says, oh, I'm getting command code sign failed with a non-zero exit code. Awesome. So in order to fix that, what you want to do is, since it's a code sign error, what you want to do is click on, all right. Connect, do you have your iPad connected, Lisette? With the cable? All right, with your phone, but is it connected? All right, perfect. Now what you want to do is you want to click on settings in your phone. So quick time. So in your phone, click on settings, and in settings, click on device management. And what do you see? Do you see the option to trust? If you see, click on trust, and that should fix this error, and you can go ahead and build again.
Wait, I go where? Device.
Click on, yes. So click on general and search for device management. Do you see an option over there? Trust.
No.
All right,
It
so,
says it's verified.
oh, it says verified. Awesome. All right, so in that case, can you build an Xcode again? And do you see any errors coming in when you build it?
Yeah, it's the same error.
All right, can you click on the name of the project, which is the Xcode project file, and
Mhm.
click on signing and capabilities? What do you see?
My team is me.
All right.
Personal team, the bundle identifier, signing certificate.
All right,
It
but do you see any
show-
errors here?
No.
All right. That's interesting. Did you by any chance happen to see a password on your screen when you try to run it initially?
No.
Did it ask you for a password? No?
No.
All right. Okay. How many signing options do you see? Do you see signing debug and signing release, or do you see anything else apart from these two?
Where is that?
In the signing and capabilities screen,
Right.
do you see anything else
No,
apart from this?
I just see signing. I don't see like debug and release.
All right, that's okay. And all right, so I have a quick solution for this. Can you firstly save the file? It's auto save, but you can quit and reopen because it will ask you for a password to fix the code sign usually. So reopen the app. So press Command Q and reopen this application.
Okay. Okay, I did.
Yeah. All right, now did it work?
No.
Now you can go ahead and build it. You still see the same error for code sign?
Yeah.
All right. Give me a moment. What does the signing certificate tell you? over there. What does it read? Do you see the
Um,
word keychain anywhere? Login keychain or something?
No, for where does it say signing certificate? Just as Apple development in my email.
All right. So you don't see login keychain anywhere, right? Login or the word keychain anywhere?
No.
Okay. So I've encountered this error before, but the way I had fixed it was when you just rebuild the app, you see the login keychain and you click on always allow and that works. Okay, another quick fix. Create a new project file, click on file, new project as an ARKit and just copy the code that you see and that image file and it should work. If it doesn't, please let me know. All right, then I'll probably think about a next step, further step.
Okay.
So create a new AR project file and just copy this. But for now, you can just commit this file, all right? And add it to the remote. So everyone, please go ahead and add this file to the remote because you have to submit this link for 20 points as an assignment in class tutorial stuff, right? So Mars in the living room. One important thing that we didn't see is the next function, and that's pretty important to understand. The function which is called view will appear. All right, so part of the entire cycle. But what is important is to see the session configuration. It says the configuration equals AR world tracking configuration. What that means is the world tracking configuration is an inbuilt type of configuration. What it allows you to do is if you see the moon in front of you, you can go towards it, you can go away from it. If you go beneath it, you can go underneath it. The moon remains there at that particular position. That is what world tracking configuration does. And it is a very powerful tool because initially the configuration would just be the moon. If you go ahead, the moon will also go ahead, right? And that's not how it should be. The world tracking configuration gives you the main three fundamentals, which is the X, Y, and Z, basically the depth property, and it will make the object stationary in the free space. This is essentially important for tracking or detection. All right, you can do so. You have AR image tracking also, which is for 2D, which is not pretty good. But what you see is world tracking configuration allows you to even do things with videos and to read some documents. Oops. I have a few things open here. So diving into the world of augmented reality, build unparalleled augmented reality experience for iOS users, and ARKit 4 is what we are using. Okay, fun question. What is the Xcode version that we are using right now? Anyone? Without seeing.
11.
Okay. Anyone wants to double check? Did you just see it and say? Because it's all right, you did not. It's 12. Also, what is the Swift version that we're using? Now, this answer I'm not sure you'll be able to find out. So this is where I was leading to. What is the Swift version that we are currently using? Like we say Python 3 and all of that.
4.
What about Swift? We are using Swift 5. This is the latest version. It is now a stable one. If you see Swift, you can just search for it and you'll see it. So remember these things, okay? You have your resources, documentation, all of that. But when you search for, you can click on developer tools and everything. Swift 5.3, perfect. So now if you see SceneKit, SceneKit allows you to create 3D games and add 3D contents to apps using high-level scene descriptions. Easily add animations, physics simulation, particle effects, and realistic physically based rendering. Overview. SceneKit combines a high-performance rendering engine with a descriptive API for import, manipulation, and rendering of 3D assets, unlike lower-level APIs such as Metal and OpenGL. However, one thing that you'll notice is whenever you've built your application in the console, in the debug console, you'll actually see Metal written, right? Metal is again for 2D stuff. So that's why you will have Metal, all right, regardless, but it's a part of the SceneKit. So SceneKit requires only description of your scene contents and actions or animations you wanted to perform. And these are the different nodes that you want to see. All right, we've actually used some of them. But what I want to actually see is world tracking configuration. Right, just give me a minute. All right, world tracking configuration. If you see AR world tracking configuration, it allows you to do device rotation and position. Now, next class, when we are doing an application of the resource view, because some of you are doing that, image detection stuff, in that, what you're going to see is to a ship or a moon or whatever you have, what you want to see is you want to add a sphere. So at the beginning, when I mentioned that you want to add a sphere to the detected image, in order to do that, we have to create a new folder or an AR resource folder, which will allow you. So you have to create an AR resource group. So I'm just showing you what we'll be doing. You'll be creating an AR resource group to which you'll be adding, let's say, the images you want to detect. So this is like machine learning, but in machine learning based application, when you use a core ML, you actually use a predefined data set, right? Or a predefined model, which comes with a lot of inbuilt properties, right? That you can detect, like we had done for the hot dog application. Over here, what you have is, let's say you don't want to detect with a model. You just want to have a few images that you want to load. Let's say you're creating an application to write description of Rutgers alumni. All right, let's say the scientists of Rutgers, something, and or historians at Rutgers. And in that application, you want to add a few images right here. And whenever you hover over any of the image or the people, um, you'll be able to see the description. So this is where in this AR resource group, you're going to add those images. Now, this would be a bit interesting or maybe a bit confusing to kind of see that the assets folder that you have is also there, but along with that, you also have the SCN assets folder, right? And then why are we adding the resource group to the normal assets folder? The reason we do that is because the SCN assets folder won't be used really, because that is not the main bundle when it comes to image detection. You want to check the image from the base assets folder. And that's why the AR resource group will actually be a part of this. All right. Also, coming to the main part, why I'm talking about this, which is when you add an image here, and let's say I add the image of this coffee mug right there. And if I have this coffee mug, and when my camera detects this coffee mug, there should be a plane in front of this coffee mug. Now, this plane, if you see our assets folder, this is a sphere. So let me add a plane. So let's say this is the plane. Where's the plane? Where's the plane? All right, so you can see a plane right here. And now what you want to actually see is this coffee mug is actually vertical, whereas the plane that you see is horizontal, right, in landscape. So whenever you are doing image detection, you need to understand the Euler angles. Basically, I'm not sure if you've done it in one of your math classes, but if you see, you can call it Euler also, right? This one, the Euler angle, which is, you see, minus 90. You want to change it to, let's say, 0, you can flip it to vertical. So that's what we have to do. And that's what the scene view enables you to do, actually. If you see the scene view, you have to, scene kit and world tracking configuration, you have to change the rotation or the position. All right. And that's why you see all of this. And to do that, what we'll be using is for plane detection. Basically, we'll be creating an AR plane anchor. So just want to introduce these things. AR plane anchor or anchor is what enables detection in ARKit. So AR plane anchor is basically, or the image anchor, it basically matches the points that you add the image to. So if you have, so basically we'll be creating an anchor. That anchor will be comparing the object that you load in the SCN resource group folder right here, the resource group folder that I created. And the anchor will match it with the real object that it sees in front of it, and then adds a plane on that image to which you can add all the different things that you want to add. All right, so it might look a really high-end or high-level observation here, but we'll be implementing this. All right, And this is exactly all the things we'll be implementing for image detection. That's what we'll be doing in the next class. Now, I really want to take some time to actually tell you what I was talking about when I was saying varying traits. If you see the assignment, where's the hackathon? If you see the question mark of the question of the hackathon, you have this calculator, and then you rotate this calculator. If you see, when it comes to auto layout, firstly, please, all right, click on this link. This will tell you exactly how to create this. All right, it's got all the steps, how to change the auto layout and all of that. Very important to understand. However, one thing that's not here is you can definitely create this page, right? It's really simple to do this. And essential to understand how to get this, right? When you flip it, it should be the same and vertically. However, if you see the question statement, it is a bit different. When you flip it, you'll see a lot more things here, which do not exist here, which means there is some property that is enabling you to add more functionality or more features when you change the landscape, right? So remember, there is something called as traits, and traits include the position. So for example, so just deviating from here a bit, if you see the main storyboard, and so no need to do this, I'm just trying to just give you an idea. So if I just add a random view controller here, and let me add a box, a button, wait, add an image view here. This is going to add a random image. All right. So just one last thing before you go, Ibrahim. Oh, all right, you're going. Goodbye. So when you flip the application to landscape, what happens is usually you'll see those applications that when you flip your screen, the image actually comes to the left side, right? And you can even change it from it, and you can even make the application, because it's your application, to when you change the landscape, right? What you can also do is this image from the left side can be positioned right here because it's your app, right? You want to do that. Then how do you make that happen? How do you change features based on the trait? Because now that I changed it, you don't see it here as well. So how do you make all of that happen? The way you make it happen is, firstly, let me bring it back here. So you'll probably be able to see it here. All right. Now, how to make that happen? If you see this file, when you are changing the direction, right before doing it, you see something at the bottom of your screen called vary for traits. All right. And that is what will allow you to make those changes, called vary for traits. Change it to landscape, click on vary for traits, select width and the height to make it very specific. And now if you change it right here, or you can even disappear that if you want that, hey, I don't want this when I change it to landscape mode. I only want to see it in portrait mode. So you can delete that also, and you can click on done varying. And now when you flip the app, you will actually see the difference, because now, oops, what's that? Oops. Oh, also make sure to have auto layout set for the first one as well. So give me a moment. So when first step would be to secure this, all right? So firstly, add some constraints here. So this should know its position, all right? So let's assume it's right here. And now if I vary for traits for the landscape mode, if I change the orientation to this, add vary for traits, width and height, I get to, and I can even delete it now from here and click on done varying. And now if I click the orientation to change, you see it in the portrait mode. And when I click on landscape, you don't see it anymore. So very important thing to know. That was a tricky part about the entire. So there were just two things about the hackathon part, which was tricky, which was to auto layout, and to flip. The code, I'm sure it's going to be super simple. I'll check it. So again, this week you'll see a lot of grades coming in, and one important thing, we are coming to the end of this course, right? We're coming to the end of this course, so just combining a lot of things together, and again coming to the testimonials part. So there are two things you have to do. I'll put the again template coming up very soon, but the fun thing is I'm also making a video, right, about this course. I've been instructed to do so, that create a video, because I make videos part-time. I work for, I'm not sure if you know Johnny Harris. Does anyone know Johnny Harris here? Vox Media. So basically I assist the filmmaker because that's something I like to do. So I'm actually combining a video about this course for this online environment. So I'll be giving out some details about certain things as to what you can say. If you were interested in doing it, we'll just make the video look much better. It's how COVID came in and how you have an online course and all of that, right? So I'll give you more instructions on that. And yeah, so that is what I'll be actually. So a couple of things, you'll be seeing some grades. I'll be putting up some instructions for the final part. May 6th is when you have your presentation. So you can mark that date, said it multiple times. And on Tuesday, I want to see your progress of the application. So I want to see your application progress on Tuesdays and Thursdays on both days. All right. So I want to see good progress, guys. This is the week where you put in all the time you have for this project, for this class, and complete it, right? So create your applications. I want to see your progress on Tuesdays, just 2 minutes. It's not graded, but I want to see progress from each and every one of you, each team. Hackathon stuff, the ones who missed the last class, please submit it by tomorrow. I'll add the extension that you see. But make sure it's done in that 1 hour in that 1 day period, because again, it's supposed to be done like really quickly. And yeah, you'll see the quiz opening again, the third quiz coming in on Tuesday. I can even, so do you guys want me to put the quiz on the weekend if that's okay? I mean, earlier the better, or do you want it to be on Tuesday itself? Any opinion on that? I can put it at the earliest by tomorrow also. So anyone with strong opinions when you want the quiz to be enabled?
When will it be due if you like put it up as early as possible?
It'll be due May 6th, because it's the last quiz.
Oh yeah, the earlier the possible.
Oh, all right. Okay, cool. So I hope instructions are clear. I want to see your application project progress on Tuesday. And yeah, please contact me if you have any questions with your project, you want to kind of think it through. But yeah, just work on it, and see you guys on Tuesday. Have a great weekend. We're coming to the end of this course, and yeah, I'll also put in some announcements for the video and stuff. But yeah, all right. So see you guys on Tuesday. Goodbye.
Thank you.